Hi, my name is Calvin Woolert, and welcome to the next in our continuation on our series on programmatic approaches to energy management. Today we're going to talk about continuous energy optimization. When most people think of sustainability or energy management programs, they think of projects. As I will describe to you in this video, projects are very important and projects can move the needle, but projects are by far not the only piece to a successful energy management program. A successful energy management program is going to involve this concept of continuous energy optimization, which is really at the heart of an energy management program, because it blends together both energy reduction with how maintenance impacts energy, how monitoring, measurement, and verification, purchasing, standards and best practice all fit into and impact your utility use. So starting over here with retro-commissioning or recommissioning, those terms are often used interchangeably, but what that means is going in and making sure that your systems are operating as they were intended, because often over time they were either never commissioned to start with and they were just turned on, which is called recommissioning. And retro-commissioning is it's already been commissioned, but you're going back and commissioning it again. The thing about this is you can achieve very quick paybacks on these types of activities. Typically, often it involves tuning and controls type stuff. But this is a periodic activity. You do it every couple of years or every 5 years, hopefully. Some people never do it, but the idea is you go back and you make sure the systems are working the way they're supposed to. Continuous commissioning, as we move around the wheel, is continuous diagnostics or continuous commissioning. That is this, but you're doing it on a continual basis. There are software packages available now, and this is really where the industry is going. And we are helping customers with this as we speak. But basically, continuous commissioning is where you're monitoring your equipment as it's running and finding out when things are going awry so that you can be proactive in your correction of problems. And obviously that has energy impacts, but it can also have service level impacts in terms of servicing your process or serving the building environment. So that has a double whammy there. And I'll show you some examples of that in the next video. Tracking and KPIs, we just discussed that in the last video, so I won't delve into that anymore, but of course utility monitoring is also buried in this, as well as having a measurement and verification program to make sure that when you do implement projects or any of these things, that you can monitor and verify that it's actually performing as expected, so that you can be assured that you're getting the return on investment for that activity. Maintenance and consumable selection. What that entails is tied to continuous diagnostics. You can monitor your equipment and decide, is it time to do maintenance on that equipment? An example would be, I have a chiller that I brush the tubes on every year. That would be periodic maintenance. Or I just run it until it fails. That's run to fail, that's no maintenance. And then there's predictive maintenance, which is where you actually monitor that heat exchanger and you can tell when it starts to get fouled. Maybe you're not brushing those tubes enough. Maybe you're brushing them too much. Maybe that chiller's not really running that much. You can look at the run hours on that piece of equipment and decide. And we'll talk about an example of that as well. Consumable selection would be something along the lines of, am I selecting the right air filter for my application or oil filter? So for an air filter, for example, you could get a higher particulate removal air filter, which may cost a little more on the front end. But it can actually filter out more material, which keeps your coils in good condition so that they don't get dirty, so they continue to exchange heat well. And there's analysis that can be done as to what is the proper consumable from a life cycle cost standpoint, not just a first standpoint. And energy can be impacted there as well. If you have a filter that creates a high pressure drop in the airstream, then that can actually save you energy. In some instances, if it's fed with a variable speed fan, that can actually cost you energy. So understanding those, they have a real impact on the facility. not just in first cost, but in energy costs. Standards and best practices, this is something that people are probably familiar with, but the way we look at it, it encompasses a much broader scope. Most people think of standards and best practices as like a compressed air leak management program or a steam trap maintenance program, but also standards and best practices handle things like equipment optimal obsolescence, which is a mouthful, but optimal obsolescence means I have an older piece of equipment. When is the proper time to retire that piece of equipment? I can buy a new piece of equipment which is going to be more energy efficient, let's say, but there's an investment to do that. But recognizing that, hey, this piece of equipment is going to die soon, do I replace it in 2 years when I expect it to fail, or do I replace it now? And you can analyze that and decide, and that's part of best practices, as well as equipment standards. Do you have standards around the purchase of equipment such that it's not putting undue demand on your utility infrastructure? An example of this, which is quite common, is companies will buy a new piece of packaging equipment, and that new piece of packaging equipment requires 120 pounds of compressed air pressure in order to operate without shutting down. That pressure then drives the needs of the entire compressed air system. Whereas if they just specified up front, hey, this piece of equipment that I'm getting bids on needs to operate at 80 psi or less, the bidders can redesign their equipment, put bigger cylinders on it so that it doesn't consume a considerable amount more energy in your compressed air system over the life of that piece of equipment, which can be quite long and costly. Also, standards such as doing things right the first time. It's amazing to me that in this day and age, but it still happens, there are plants which just did a plant expansion or remodeled an area, and you go into that area and there's 400 watt metal halide fixtures in there, which could have been high bay fluorescents or even LEDs nowadays. And the money that they spent on those 400 watt metal halide fixtures, if there could be a lot of them, basically it's money that was completely wasted. You could take those fixtures out, throw them in the trash, and be cost effective at replacing those with a different set of fixtures. So it highlights the fact that there's nothing more expensive than doing something wrong the first time, because that money was totally wasted buying the wrong equipment. And that is a standard. You know, what is our lighting standard in this type of application? What types of things, what types of fixtures should we be putting in? Do occupancy sensors automatically come with them? Is that part of our purchasing requirements? And also, with standards and best practices can also include employee engagement and using KPIs and tracking, as well as your programs to incentivize employees to bring up new ideas, to help get on board with the overall goals of the organization in terms of sustainability, to provide that positive feedback. So in the next video, I'm going to show you some examples of continuous diagnostics and real-world examples using actual data of how this can be a powerful tool. Thank you, and for more information, please contact us.